Hello students. So we'll be moving into the next type of synchronization, that is a mutual exclusion algorithm. See, in the mutual exclusion is nothing but already we have discussed this a number of times in the operating system concept, where mutual exclusion will be under process synchronization, where we have to utilize the resources according with the process. So if there is only one resource and there are 5 processes, so all the 5 processes require the access of this resource. Now, how to utilize this resource by process 1, process 2, process 3 and process 4 and 5. So that will be the mutual exclusion concept. See how means we will be like in the general operating system, we will be following the mutex locks and all. So when I am utilizing a particular resource, I will lock that resource for some time and P1 will be utilizing that. When any other process like P4 comes and enters and sees that critical section, so that is under usage, so I have to wait for some time. So P4 will be understanding that procedure and that will be waiting for some time. Unless until P1 releases this resource, P4 will be in the queue. So to after this release gets and the message which is notifying to all the resource, all the processes, immediately P4 enters back to the resource. So every time we have to lock the system and utilize that, and when we are leaving outside of that resource, the process must release that. That is nothing but we have to unlock the resource and then we have to go, so that the other processes will be getting the chance. So that is what the importance of mutual exclusion. So coming to the distributed systems mutual exclusion algorithm, for the synchronization purpose we are going to include 4 types of algorithms as we have listed here: centralized, decentralized, distributed and the token ring. So we will be going to discuss everything in detail about every concept in detail. Now coming to what is mutual exclusion first. See, mutual exclusion is nothing but we are going to communicate with the shared processes. So there will be 5 processes. All the 5 processes must be in the shared procedure to utilize a particular resource. So that is what we call that as a critical section. So critical section is nothing but at a time only one process must utilize a resource. That is the condition which we follow. Right. So now when process 1 enters, we have to say the other processes to wait for some time as critical section is busy. Right. So that is what the critical section is very important in the mutual exclusion concepts. Now coming to the distributed mutual exclusion, how we are going to deal with that will be a challenging thing to us. Right. So there we will be going with the 4 algorithms as we have just listed: centralized, decentralized, distributed and the token ring. Now we will be moving to the first thing, that is a centralized algorithm. See, centralized algorithm is nothing but, as we are in a distributed environment who are communicating with each other, every process will be in communication with the all other processes. So this scenario we know. Now every process will be electing one process as one of the coordinator. So if I have 10 processes, out of 10 processes, all the 9 processes will be selecting one process as a coordinator. Now, whoever is selected as a coordinator process, that process is responsible to give access of that particular resource to all the remaining 9 processes. So that is what the centralized algorithm is. Here, the shared resources must be given to a process when it requests for the resource processing. Now, every time coordinator will get a request thing from a process. See, a resource R1 is there and P1 is selected as a coordinator. Now P2 and P4 want to utilize this resource R1. Now what to do? Now P2 and P4 will give a request to the coordinator that I want R1 resource with the name of the resource, with their process ID. P2 and P4 will be giving the request to the P1. Now among those two, P1 will be selecting one, whoever comes first with the timestamp complexities. So that particular process will be getting a chance to utilize the resource. Now, whoever is getting the chance, P1 as a coordinator will be giving an OK message, then immediately P2 will utilize that. P4 is not getting a chance at that prompt, right? So what P4 will be doing is, it will be waiting till P1 gives some reply to the P4. So after P2 utilizes, P1 will be giving chance to P4 back that with a OK message. So that is what the procedure is. See, if you see the diagram here, we have 3 processes over there and we have one coordinator over there. Now 0, 1 and 2 processes want to utilize this resource. Now what coordinator will be doing is, it will be taking all the request from the process. Now process P1 is giving request to the coordinator saying that I want this resource. Now coordinator received it. As it got only one request, it will immediately give response back to the process saying that you can utilize OK, because the queue is empty, right? Because no one is utilizing that particular resource at that prompt. So this is one point. Now coming to the second point, at the same time when one is utilizing the thing, at the same time Q entered, right? P2 entered. Now P2 entered to the coordinator, right? So coordinator will not respond anything. See, no reply we say, because one is utilizing the resource, that 2 must wait in the queue, right? So once one releases that, one will be giving a notification to the coordinator saying that I have completed the utilization of the resource. Now immediately you can leave me from this particular resource utilization. Thus the coordinator will be giving an alert to the other process which is in the ready queue, stating that I want the resource, right? So immediately 3 will give an OK message to 2 stating that you can utilize the resource now. So this is a whole process which takes place in the centralized thing. Now moving to the decentralized. See, decentralized is nothing but there is no combination of the coordinator kind of thing. All the processes will be having the equal chance, right? Whenever they get chance to utilize the resource, they will be utilizing it. Whenever the process needs a particular resource, that process must win the majority of the votes. So that is the only thing which we can discuss in the decentralized, right? So here the number of votes plays an important role, because out of 10 processes, P2 is requesting for the resource. Now P2 will ask all other 9 processes stating that I want this resource. So among all the votes which it gets, immediately that will be getting the chance. So let us assume P2 and P4 are asking for the resource. Now P2 got 3 votes and P4 got 6 votes. So P4 will be getting chance to utilize the resource. Got this? So this is about the decentralized thing. There is no coordinator or it's just a process combination here. Every process will be having the equal chance. Now coming to the distributed algorithm. So why we are moving to the distributed algorithm means in the centralized, if a particular coordinator, as we are saying, coordinator is there every time. So if the coordinator gets failed, so everything collapses, right? Because the who is giving chance to utilize the resource is gone. Now every process will be in the waiting state, leading for the starvation. So starvation is nothing but you'll be waiting for a person who is already dead. So that will be always, you will be under waiting state only. So that is what the starvation is. So that kind of cases we can overcome in a distributed environment. So in the distributed environment, as similar to the coordinator concept only, but here we will be having a different case that every time we will be taking every process who wants to utilize the resource, the shared resource, every process will be getting the equal chance, stating that I have received all your request. Now, who will be getting a request message? All other processes in the ring. So if you can see this, see n number of processes are getting a chance. Now 0 is having the resource utilization request. So it has sent, now 1 and 2 gave that opportunity to utilize with the OK message. Now O started utilization. Now when O is getting released, it will give chance to 2, because 2 is also asking for the resource utilization. Like this, in a circular motion, in a combination, means in a synchronization format, distributed environments will be utilizing the resources properly. So here, see, if a receiver is not accessing the resource, see, as we are saying, who is there is sender and receiver. If the receiver is not accessing the particular resource, see, I am the sender and there is one receiver. So I will be asking my receivers, like everyone will be in the process, in the distributed systems will be called as the receivers. only I will be called as a sender, right? Now when I am asking all the receivers that I want a resource. Now if the receiver is not accessing, it will give OK message directly because it is not utilizing, right? So like that I will receive all the OK messages first of all. So once I receive, I will start utilizing the resource. Now if the receiver is already accessing the resource means it will not give any reply for some time. After it completes the usage of this resource, it will be giving the request, right? I mean OK message. Till that time the process will be in the queue and a waiting mode. Now if the receiver wants to, if the receiver has 2 more extra processes, utilization or the timestamp, depending on the timestamp who comes first, that will be getting the chance. So this is what the distributed algorithm is. Now coming to the token algorithm, this is a fair enough algorithm giving equal chance to all the processes in the network. Now what happens in this is we will be maintaining a token that is nothing but an integer or a key variable, whatever it is. We will be maintaining a token. So this token will be moving from one process to the other process. See here, this is an unordered list. This unordered list we are arranging in a ring format, in a sequence format. Now the token will be moving from 0 to 7 back. Now when we are utilizing this, who want that particular resource will be getting that token. So when they get the token, they will utilize the resource. So token plays an important role here. And when the token reaches here, immediately this will be getting the chance to utilize the resource. So thus there is no starvation at all and mutual exclusion will be properly done. So this is about a token ring concept. Now when we compare all the algorithms, the only problems which we arise are centralized will be problem when the coordinator gets crashed, every processes will be under waiting mode only. Now decentralized, it will be leading for the starvation because we are dependent on the peer entities processes. Now distributed is nothing but same as usual. If any of the process in the distributed environments gets crashed, everything collapses. Now token ring, see if the token itself lost means everything gone. So token will be moving all around the processes, right? So if the token gets lost, then our process may be crashed out and we will be in the starvation mode, right? So this is all about mutual exclusion algorithms. If you have any doubt in this, please be free to contact anytime. Thank you.